This is part 3 of my nuclear fusor build. In this section, I'm setting up the high voltage power supply and constructing a diode rectifier to convert the 10 kV AC from my neon sign transformer to 5 kV DC. I made two versions of the diode rectifier. The first did not work at all, and the second version worked perfectly, but I'll get into that later. Right now I'm building the doomed first version. Here I'm soldering two 20 kV diodes together. I'll put a picture up to show the configuration. This is the way most fusors convert AC power of a neon sign transformer to direct current, which is vital for steady operation of the fusor. Here's the rectifier wiring. The black wires are the AC inputs from the neon sign transformer, and the green wire is the DC output. Each wire has a ring terminal crimped to the end of it. Next, I threaded the component through a PVC T and screwed the terminals into the end caps. Next, I attached the caps to the T. You can see how the screws act as standoffs to connect the terminals from the NST. I filled it with mineral oil after a considerable struggle getting it to not spill everywhere. I crimped fork terminals on the ends of the neon sign transformer output wires and two ring terminals on the ends of some high voltage wire I just got off of Amazon. This red wire will bring power from the rectifier to the high voltage feed through of the fusor. At this point I thought the fusor was ready to fire up, so my vacuum pump arrived. I plumbed it to the fusor chamber via some 3/8 inch ID, PVC reinforced vinyl tubing, and some hose clamps, and began running the fusor. I'll put up the wiring diagram again to help make sense of everything on the table. As I began adding power via the variac, I noticed that absolutely nothing was happening. After using a voltmeter to test the components, I identified the issue to be happening at the output of the rectifier. To make matters worse, a vacuum leak developed somewhere in the chamber. I didn't know where. I could just hear a hissing sound coming from the fusor. My workaround to the rectifier issue was to simply ditch the original design completely. Instead, I opted for this bridge rectifier, using 4 diodes to convert the voltage to direct current. With this design, I have two DC outputs, negative and positive. So instead of grounding the chamber like most fusors, I connected the fusor to the positive lead and the grid is negatively charged. I used 4 1032 screws and hex nuts to create 4 standoffs for the inputs and outputs of the bridge rectifier. I put it in a soap box I cut in half and cast it in epoxy resin to prevent arcing. The vacuum leak was a result of the chamber not being tightened enough, causing the gaskets to be sucked inside of the chamber when I turned on the vacuum pump. So I reinstalled the gaskets with more vacuum grease and used a wrench to really tighten the hex nuts on the top. When I fired up the fusor again, it actually worked this time, but that'll be in the next video.